Hello, everyone. Welcome to Session 1 RETScreen Innovation Lab at the RETScreen World Conference. The RETScreen Innovation Lab ensures the software is always at the leading edge of the clean energy technology transition. It achieves this by continuously improving to meet the needs of the RETScreen's large and rapidly growing global user community. In this session, we'll hear from Faezeh Mosallat, who will introduce us to RETScreen's new deep retrofit archetypes in version 9. Following Faezeh, Nathalie Meloche will delve into other new features in RETScreen version 9. Last but not least, Paul W. Stackhouse Jr. will share the latest developments with NASA Power Data for RETScreen. Let's now turn things over to Faezeh and deep retrofit archetypes.
Hello, everyone. Welcome to this session of RETScreen World Conference. In this session, we will go through the new deep retrofit archetypes, which are available now in version 9 of the software. You can find them in the Virtual Energy Analyzer feature, which is one of RETScreen's smart features that allows for rapid and accurate estimation of energy consumption and saving potential for any location across the world. The Virtual Energy Analyzer includes various and several archetypical facilities such as power plants, cogeneration, off-grid storage, different types of real properties, and also transportation. So before I start going through the deep retrofit archetypes, I just want to give you a brief explanation of what an archetype is and why we create them in RETScreen. So when you want to start a feasibility analysis in RETScreen, you have two options. You can start a blank project by clicking on a feasibility icon here. So this is when you have enough information about your facility, you know all the details, and you feel comfortable enough to start everything from scratch. So whenever you open a blank feasibility analysis, you will need to go to the location worksheet, set the location of your facility. In the facility worksheet, you define some information about your facility, what type of facility it is. Is it a power plant, cogeneration? Is it a real property? Let's say it's a commercial institutional property. Then you go to the type of the building, you choose the type of your building here. Let's say it's an office. And then when you switch to the energy worksheet, you see that everything is blank. So you need to go through all the steps in the top ribbon and set up your project. You need to set your electricity and fuels, schedules, heating and cooling equipment, and also you need to set all your end users, such as building envelope, ventilation, etc. You also have the option to add some renewable energy to your project. So what if now you don't have enough information about your facility or you don't know where to start from? That's when the Virtual Energy Analyzer and the archetypes become helpful. So you can now go through all the facility types that we have available. You can find the archetype that suits your project the best. And with just 5 clicks, 80% of the job will be done for you in less than 10 seconds. So for example, I'm going to open the office building and an office medium in the same location that is already there. It's Montreal in province of Quebec, Canada. And when I click on calculate, the software pre-calculates all the results based on the climate data of the location that I chose. So you can see the climate data of the location here in the location worksheet. Then you can go to the facility worksheet. You see that it's a commercial institutional office building. And you can go ahead and enter more information if you would like. There is also a schematic of the building here in the image section. And when I go to the energy worksheet, you see that everything is already set. You have your electricity and fuels with the rates. You have your schedules, heating and cooling equipment are set, and all the end users are set for a typical office building. So Then you can go ahead and check all the forms, see if you would like to change one of the values or one of the parameters. You can add or remove any of these end users. Let's say you have, for example, a compressed air system in your building. You can go ahead and add the form from the end use menu. And at the end, you have the option, as I said, to add some renewable energy to your project as well. When we go to the summary section, in the include measure section, you can see that there is the list of all the equipment and end users, and there are some checkboxes. So by checking and unchecking these boxes, you will include or exclude the energy efficiency measure on that specific equipment. So when, for example, when I go to the office ventilation, you see that the energy efficiency measure is included. I open the form, you see that we have a base case and proposed case. So for all the forms in the energy worksheet, we have a base case and proposed case. When we say base case, it means the existing state of your equipment or your end use. And proposed case is after you apply energy efficiency measure. For example, here we reduced the amount of fresh air and also we adjusted the schedule. So when I go to the include measure form, and when I check this box, it means that I am considering that energy efficiency measure on the office ventilation system. If I exclude it, it means that I'm considering the base case being equal to proposed case. Then in this page, you also can review the amount of your energy or fuel savings or energy and fuel consumption of your base case and proposed case based on what you choose here. In the comparison worksheet, in the comparison form, you also have the option to review the amount of fuel consumption for each type of fuel that you have in your project for the base case and proposed case. And also you can review the fuel consumption for the heating, cooling, and electricity. So in addition to all the archetypes that were already available in previous versions of RETScreen, we have added a second level of archetypes into 30 archetypes in the virtual energy analyzer. 15 of them are under commercial institutional facility type and 15 are under military. So for example, if I go to the commercial institutional and then I open the description for the office building, you can see that now we have two categories. The first one, which is the one that already existed in the previous versions of the software, is based on applying cost-effective energy efficiency measures to reduce the energy consumption by 30 to 40%. Now we have a second category, which is based on adding more advanced energy efficiency measures. Some of them may not be cost-effective anymore, to reduce the GHG emission by 80 to 90%. So these are called deep retrofit archetypes. For example, the one that the archetype that I already have open here, the office building, is an example of the 30-40% energy consumption reduction, as you can see here. So you can go ahead and review the measures in different forms and see how it has been implemented. You also have the option to review the explanation of each measure on each of the end users by clicking on the note button here in the top ribbon, and you can review what measure has been done on the building envelope, for example. Then you can go to the form itself and see how that measure has been implemented in the software. You also have the option to review your costs in the cost worksheet, review your emission reduction and the GHG emission factor of your electricity grid here. You can review the financial viability of your project in the finance worksheet, and then you also can do risk and sensitivity analysis in the risk worksheet. Now, let's move on to the main subject of this session, which is deep retrofit archetypes. Before I show you some examples, I am going to briefly explain what these archetypes are and how they work. So these archetypes incorporate artificial intelligence to help users prepare pre-feasibility studies, in a few seconds for potential deep carbon emission reduction projects. So the target is to eliminate at least 80 to 90% of GHG emission for each facility that is being assessed. That's why we call these deep retrofit archetypes intelligent, because as soon as you choose your location and you click on calculate, the archetype is going to first adjust the heating and cooling load of your building based on the location that you chose. This is what already being done by the other archetypes, the 30-40% energy reduction versions. Second, they are going to electrify the proposed case heating system. They will choose between 3 different technologies: electric boiler, air source heat pump, and ground source heat pump. Third, they will check if we need to reduce more GHG emission to reach the target of 90%. If we need more, the archetype will calculate for you the amount of on-site renewables, such as, for example, photovoltaic system that you need to install to reach the 90% goal for the GHG emission reduction. One more thing that the archetype checks is the amount of electricity consumption in the proposed case. So why does it do that? It's because when you electrify your heating system, it means that you are increasing the amount of electricity consumption of your building. At the same time, we don't want to increase the demand on the grid. So that's why we need to consider some measures to reduce the amount of electricity consumption well below the amount that was in the base case. So this will also be checked by the archetypes. Now I'm going to open an example of deep retrofit archetypes to clarify what I just explained to you. The archetype that I'm going to open is under military type, and it's going to be an industrial workshop. I will choose it from the second category, and I will open it in 3 different locations across Canada. I chose 3 locations with 3 different climate and also 3 different electricity grid carbon footprint. So the first location is going to be Vancouver in British Columbia, Canada. So now when I open the archetype, it will do all the 3 steps that I just explained for you and opens the archetype. The first thing that I would like to check is what technology for the electric heating is being proposed. So you can see that it's electric boiler with 100% of efficiency. When I go to the target, I see that we have reached 94% of GHG emission reduction. I go to the comparison form, I check my electricity consumption in the proposed case. I see that it's well below the base case. It's almost 75% of the base case. And when I check the include measure form, we see that we don't even need to install a photovoltaic system. You can see that it's unchecked, so we don't need to install any renewable energy. We just achieved both our goals, 90% of GHG emission reduction and less electricity consumption in the proposed case. In the emission worksheet, you can see the GHG emission factor for British Columbia. You see the amount of reduction. And when I go to the finance worksheet, you see that the project is still financially viable because the electric boiler is not an expensive technology. So we were able to keep the deep retrofit project still financially viable. The second location that I would like to move my building to is going to be Montreal in Quebec province of Canada. So what is the difference between these 2 locations? Montreal is going to have a colder climate and a much cleaner electricity grid compared to Vancouver. So when I say that, I kind of expect to have an electric boiler with an efficiency of 100%, and this will allow us to reach the goal for the GHG emission because the grid is so clean in Quebec. But we can see that we have air source heat pump with efficiency of 150%. So we know what is the reason for that. It's because we have a colder climate, so the heating load is going to be higher When we switch to electric heating, it means that we are increasing the amount of electricity consumption of the building even more than the one in Vancouver. So to reduce that below the amount in the base case, we need to have a more efficient electric heating equipment. We also need to install photovoltaic system which covers 22% of the roof, and this will allow us to achieve our goal, which is going to be almost 100% of GHG emission reduction and also less electricity consumption. In the emission worksheet, you can see how clean is the grid in Quebec compared to Vancouver, which was 0.018. And in the finance worksheet, we can see that the project is less attractive in terms of financial viability, because air source heat pump is an expensive equipment to be installed. The third location that I would like to put my building in is going to be Cold Lake in the Alberta province of Canada. So what is the difference between this location and the two previous ones? This location is colder compared to the other two, and it has much dirtier grid, electricity grid compared to the other two. So when I say that, I am expecting to have a much more efficient electric heating system. When I go to the space heating, you see that it's a ground source heat pump with a much higher efficiency. And to be able to achieve the goal of 90% GHG emission reduction, you can see that it's just above 90%. And also reduce the electricity consumption in the proposed case, other than having a much more efficient electric heating equipment, we need to add a larger photovoltaic system on the roof, which covers 50% of the roof instead of 22. And we also need a 25 kilowatt ground mount photovoltaic system. Then in the emission worksheet, you see how dirty the grid is. The GHG emission factor is 0.63 compared to 0.001 for Montreal. And in the finance worksheet, we see that the project is even less financially attractive with a simple payback of 30 years. This was actually all about. I wanted to show you one more thing that I would like to show you is that when you go to the include measure form, you see that there is an offsite renewable form here. So what the archetype does is that it calculates for you the amount of offsite renewables that you need to purchase to be able to reach the net zero goal, which is 100% of GHG emission reduction. So when you check this box, it will calculate for you the amount of offsite renewable that you need to purchase to reach the net zero goal, that is almost 100% of GHG emission reduction. This is what I wanted to show you about the deep retrofit archetypes. But what I would like to show more is that in the setting page, we have some new features in version 9 of the software. The first one is to be able to do a life cycle cost analysis on your project. I know that these days people would like to do a life cycle cost analysis on their project. So with this feature, it makes it easier for you to do that. So for the method of the financial analysis, you can choose LCCA, and it will set all the parameters that you require for LCCA. So in this case, these parameters are based on the guideline from Government of Canada. So Government of Canada asks us to use these exact values when we do life cycle cost analysis on Canadian projects. But you have the option to go ahead and manually change any of them that you think suits better for your project. So based on the location of your project or other parameters, you can just go ahead and change them manually. So when we switch to LCCA, which is life cycle cost analysis, the project life will be considered as 40 years. We will consider a shadow price for carbon as $300 per ton of CO2, and we also consider the GHG emission factor to be 0. Now, if I go and open the exact same building in the exact same location, which was the Cold Lake, Alberta, we are expecting to have 100% of GHG emission reduction, obviously, because as soon as we switch to electricity, because the emission factor for electricity is assumed to be 0, we are going to have 100% GHG emission reduction. So we check the target, we see, yes, it's 100%. And to reduce the amount of electricity consumption in the proposed case to less than 75% of the base case, we need to have an air source heat pump this time instead of ground source heat pump. In the cost worksheet, we need to enter some periodic costs as well, because the life of the project is 40 years. So some of the equipment need to be replaced in less than 40 years. For example, motors need to be replaced every 20 years. So every 20 years, we need to spend $7,000 to replace the motors, for example. In the emission worksheet, we see that we have a zero GHG emission factor, and the shadow price is also entered on the bottom of the emission worksheet. The other two features that are new in the software is that now you have the option to choose between having different emission factors, current emission factor, the projected value or the value from RETScreen database, zero emission, and user defined. Same for the electricity and fuels rates. We have created a database here in RETScreen that gives you some default values for electricity and natural gas rates for Canadian provinces and also for USA. You also have the option to add a user-defined database. You can add as many fuels as you like, and you can add the rates for them. You can add your own country and region. And when you choose here for your electricity and fuels to use the database, whenever you open an archetype or your project, those rates that you enter will be automatically pasted in the electricity and fuels form here. Okay, so this was all I wanted to cover in this presentation. I hope that you enjoyed listening as much as I enjoyed presenting to you. Thanks a lot for joining and listening to this session.
Thank you, Faezeh. Coming up next, Nathalie delves into other new features in RETScreen version 9.
Hello, I'm Nathalie. Welcome to this presentation of the RETScreen World Conference. So now what I would like to do is talk about databases. So on a yearly basis, when we update our software, we want to provide you with new databases, updated databases, so that you could use them and so that we could stay also up to date. So this year we have done a lot of improvement in our databases. So one of them, and I will click here now to Power Plant, in order to show you that that nice bar graph have been updated to January 1st, 2022. So that bar graph is showing you energy production costs for various technology that are considered into RETScreen in terms of dollar per kilowatt hour. So we could see here that, for instance, we have some very conventional technology, such as a gas turbine, but also renewables, such as photovoltaic, wind turbine, hydro. And if we bring the mouse over, we could see here the minimum and the maximum that you should expect as an energy production cost. So this has been updated. If you want to know a little bit more about how we calculate that with new efficiency and cost data, then you could look at this table that is accessible from the ribbon in order to read about the key assumption. So that benchmark or cost database has been updated along with all of the cost database included into RETScreen, the light, the motor, the pumps, all of it has been updated to January 1st, 2022. We have also updated our product database. So for product database, we updated the photovoltaic database with new PV modules. So hundreds of them have been updated along with the manufacturer, the capacity with the efficiency. We have updated also our transportation database. So we have into RETScreen a transportation tool that is doing energy efficiency calculation for various types of vehicle, of transportation vehicle. And this year we updated the on-road vehicle product database with new data. So it could be electric vehicle or conventional vehicle. It could be car, truck, minivan, SUV. So if you bought a new car during the last year, you will be able to find that into the database, because now we have cars for 2022 available into it. We also did our annual greenhouse gas emission database update with new data to update it as of 2021. And in the greenhouse gas emission factor database, we also added for the grid electricity projected data. So that could be useful, for instance, if you want to plan for the future. So for instance, you may want to do a feasibility analysis where you want your facility to become net zero ready, expecting that the grid will be cleaner over time. So these databases could then be used into RETScreen. We are now going to stop talking about database and move to the performance analysis of the tool. And in order to show you the new feature of performance, I'm going again to open an example from the facility type example column here. So these examples have been integrated into the tool, I believe, into version 8.1 with feasibility analysis. So each of them contains a feasibility analysis, each facility type. Now what we did, we enhanced those examples in order to tell you the complete story of those facilities. So what we look at is not only feasibility analysis, but also the data, the analytics, and the reporting. So I will open one of those examples right now. We are going to choose here industrial, and we are going to observe that together. So here is first a feasibility analysis that was integrated. We choose an equation, then we do the modeling of this particular plan that we are looking at. And then we propose multiple energy efficiency measures in order to reduce the consumption of fuel. So we estimate the fuel saving first. And then what we do, we go into the data sheet and we import for you data before and after implementation of these energy efficiency measures that were proposed into energy. And then we provide you also with the event log to give you the schedule of implementation of each of them, one after the other over time. And then what we do, we go into the analytics and we perform an M&V analysis in order to be able to show you, for instance, into the QSUM graph, the impact of each energy efficiency measure through time. So every time you see here a change into the slope, you could read the name of the energy efficiency measure that was chosen, and then you could see the impact that it had on the consumption of fuel. So those that are familiar with ISO 50001 will recognize that these are the exact steps that you need to take if you want to get the certification for ISO 50001. So this will be discussed during the conference as well by 3M. We have also included a custom dashboard. For each of the examples, these custom dashboards are different. We wanted to give you some variety into the type of report that you could do. Each of them will contain a report for feasibility, a report for performance. And the good news is that into the report for feasibility, we added some new table, some new graph that you could drag and drop into your analysis in order to do your own report. And this one here is a good example. We now have a pie chart that is giving you the end-use distribution in terms of percentage for your feasibility analysis. Now I'm going to move into the data sheet and talk to you a little bit more about the performance analysis. So in the performance analysis, last year into version 8.1, we introduced the possibility to import sub-daily data. So hourly data, 15 minutes data if you want, and the possibility also to connect to your metering system or to your databases. So this year, as promised, we added also some more connectors. So you could see the list of all the icons, so all the connectors that have been added to RETScreen Connect, along with one very special one here that is called Energy Plus. So again, here we establish a link to the Energy Plus modeling tool. Let me explain how it could be used into performance analysis. So when you want to do your M&V analysis, usually you are going to use monitored data. But if you do not monitor data at your facility, the protocol for M&V is telling you there's the possibility to do an energy simulation of your facility. And then you could use that as a baseline in order to do your regression analysis. So that's the possibility. So we are opening now the door to do that very easily in RETScreen. You import your data from Energy Plus on an hourly basis, and then you could use that to build your regression analysis and do your M&V. In RETScreen, you have the possibility, of course, to report on energy and greenhouse gas emission, but you have also the possibility to report on other things, so those that we call Scope 3 reporting. So here is how you could report on Scope 3. So we have other option here, and we have two very good examples. So waste production as well as water consumption. And remember that we have also user-defined that you could use to report, for instance, on air travel, commuting, and other Scope 3 analysis. So this year, into waste and water, we have done some improvements. So it was there before, but we made it a little bit more complete, and we made sure also that it could be reported at the portfolio level. So if we look at waste production, you could see now that you could very nicely select your waste type. You could also select your disposal method. So now I'm going to move to another section of the software again. So this will be the last section for today, the portfolio analysis. And again, in order to describe that portfolio analysis, I'm going to click on an example. So let's click on my portfolio example. So internally, into the RETScreen team, we call that our RETScreen laboratory because it contains example of data tracking with real data that are coming from our department, Natural Resources Canada. So you could see here, each row in the portfolio is a facility of Natural Resources Canada for which we are gathering real data. And what we try to do is to tell you the story of those facilities over time. We update it on a yearly basis. So I'm now going to use that performance analysis that we are doing in order to show you what's new into the dashboard of the portfolio. So into that very nice graph now, you could see that we care a lot about greenhouse gas emission at Natural Resources Canada. This is our main graph. And what we want to do, we want to reduce our greenhouse gas emissions. So you have the data here from 2005 to 2022. So this is the new bar that we added this year. And if you mouse over here, we could see that we were able to reduce by 52.4% our greenhouse gas emissions so far. So this is not a new graph. This is a graph that has been there since the beginning, along with the ranking graph, the saving graph, and the comparison graph. So you have many options at the dashboard level. And this year we added what we call the pie chart. So if we look at the pie chart for that particular analysis that we were looking at, you could see very nicely here the pie chart with the contribution of emission for each of the different facility of my portfolio. So that could be very useful, for instance, if you want to prioritize. So if I was responsible of that portfolio, I would probably try to see if I could reduce the emission from the Bales Corners complex that is representing more than the third of all the emission for my portfolio. So now I'm going to move into the custom dashboard in order to show you that at the portfolio level, we also have a custom dashboard, and in order to show you that this bar chart is also available for custom dashboard. Along with that new graph, we added also, as I mentioned before, the possibility to report on water and waste into the portfolio level. So now let's move again into the portfolio and start looking at what you can do at the portfolio level when you have multiple feasibility analysis. So here we are showing you a couple of sub-portfolio, and I would like to bring your attention to the new example that we brought into the portfolio this year, along with a new methodology that could be done into RETScreen, called the life cycle cost analysis. So this is becoming to be well-known approach in order to do analysis and to propose project. We adopted that into the government of Canada. So now every time we propose new project for a facility at the government of Canada, we need to bring a life cycle cost analysis that is done into 4 scenarios. So you could do that in RETScreen. So let me describe what it is. So first of all, so you start with feasibility analysis, you model your facility. This is your scenario 1. The model of your facility is then used for scenario 2, 3, and 4. So in scenario 2, you are going to take that base case that you just prepared for your facility, and then you propose greenhouse gas emission reduction with energy efficiency measure and renewable in order to get a financial profile that is attractive. So you want to have a cost neutral, net present value that is positive for your project. So that's the cost effective. That's equivalent to the 30-40% archetype. Then the scenario 3 will be the scenario where you want to propose measures in order to maximize greenhouse gas reduction. Into that case, you're not going to worry too much about the cost effectiveness of your project. In the 4th scenario, again, you're going to reduce greenhouse gas emission, but this is the scenario of your choice. This is the one that you want to implement, and you are going to optimize in order to get as much reduction in greenhouse gas as possible with what you consider to be a reasonable financial profile. So into each of those scenarios, the government of Canada is asking us to apply a shadow price for carbon. So our shadow price is $300 per ton of CO2, and this will have the impact of modifying your financial viability for your project. We are going to enter that into the emission sheet, and into the next presentation, we will show you how to do that. And this will have the impact if you decrease greenhouse gas emission into your analysis to make your feasibility, your viability for your present value will now suddenly increase, and it will have the exact opposite effect if you are increasing greenhouse gas emission. Then it will ruin your financial viability for your project. So what you do when you do a life cycle cost analysis, you prepare your 4 scenarios, you put them into a portfolio, and then you could go into the dashboard. You could build some graph, some table in order to compare those 4 scenarios, and you could bring them into a custom dashboard in order to show the result, to compare the result of the 4 scenario and justify the choice that you have made into the scenario 4. So this could be shared into a report, or it could be discussed during a presentation with your colleagues. So I'm now going to show you the last feature of the day, returning into the portfolio again. So some of you may have large portfolio that contains data for hundreds of facilities, 300, 400 facilities. So let's say that you want to change your target. So this required for you to open each of your files in order to modify your file. So in order to help you save time, when you want to do something like this, we prepared what we call an edit portfolio option. So let me give you some example of what you could do into the edit portfolio option to, in one click, modify hundreds of files if you want to into your portfolio. So if you go to the target section, I'm going to show you very simply, you can modify your target. So I'm going to scroll down get to the emissions section and show you that, for instance, you may want to change that target to 100% reduction by 2050. And then you click on OK, and automatically it will change your target into all of your files. If you want, for instance, to go into your feasibility analysis for a group of files into your portfolio in order to download an archetype of your choice, this could be done also with this feature. If you want to start, so let's say that you are having tracking of energy and you want to start doing some M&V, some normalization using the analytics, and you haven't started yet. You might want to do it right from this interface. So the first thing that you could do, you could click on degree days here and automatically calculate your degree days in each of your files. Then you could select the regression analysis, click on create regression analysis, and step by step add more regression analysis to it. So for instance, I may say, I want to do it on natural gas first, all the natural gas table. I want my factor of influence to be the heating degree days, the production, and the occupancy. It could be multivariable as well. You could select your baseline period for your regression analysis, and then you could select the type of graph that you want to perform into the analysis. And it will prepare the regression analysis for all of your files. You could go into the custom dashboard, and you could say, I love those custom dashboards, but I don't want to prepare an individual dashboard for each of my files. So then you could create your new dashboard and use the generic dashboard that we have created for you for both feasibility and performance analysis. You click on OK, and automatically all of this will be done for you. And then you could go into the portfolio and look at the result of all of this on your portfolio, or you could open individually each of your file and do the required engineering to complete your analysis. This is now the end of my presentation. Thank you very much for your attention.
Thank you, Nathalie. Greatly appreciated. Now over to Paul to learn about the latest developments with NASA Power Data for RETScreen.
Good morning. My name is Paul Stackhouse, and I'm really excited to participate in this RETScreen workshop and give the RETScreen user community some more information about the data products that we have been developing and maintaining for NASA as RETScreen has grown through the years and as we have grown. So just want you to see all the names of those who have helped us in our project and have helped us and with the content of this particular presentation as well. The first question you might have is, well, what is NASA Power? What is Power? Power is a project under the Earth Applied Sciences in NASA that we entitled Prediction of Worldwide Energy Resources. And within our Power project, we have a 3 community focus. We focus on the renewable energy development community and technologies. We also focus on the building energy efficiency and sustainability, and even agricultural agroclimatology applications. And what we do within those communities is work with them to customize formats and units and parameters, data parameters at the surface of the Earth, built around solar irradiance and related parameters, so that those communities can use those data parameters readily to make decisions. These data products are pulled from our various different projects around NASA, that from either satellite analysis or also modeling analysis, and I'll describe how we get the products a little bit later. So we have this 3 community focus, and this slide shows a bit of our evolution over the years. We've been working on this project in different names through the years, but we've been working essentially about 25 years. When in the late 90s, we were approached by the National Renewable Energy Laboratory as part of DOE in the United States, and requested some data for Africa because they didn't have any solar irradiance data for Africa for a project for solar refrigerators. And within a year or so, we met Greg Lang and his team interested in developing a decisions tool to support renewable energies. And so we go back that far with RETScreen. In the beginning, we just had a 4-year climatological data set of surface solar irradiance. And through the years, NASA research and with new missions, we've improved those products. For instance, we expanded to 8 years, and then we expanded to a low latency data product here. If you look at the bottom of our of this slide, you see various different stages. Then we expanded to a 20+ year data product. And finally, now today, we have over a 35-year data product at the daily resolution, and now a 20-year product from hourly starting at about 2001. And up the top, we've added other agencies and partners through the years, and now have actually added lots of web-based data visualization and GIS compatibility to our data products, services, and data formats. So how do we work? What is our ecosystem? Well, the first thing we do is we communicate and talk to users such as the RETScreen community. In fact, we'll put RETScreen on here because they're one of the initial, the team is one of the initial people that helped, we helped communicate with to understand what they really needed. And I was on some of the science teams developing some of these data products. So as we interacted with the community, we were able to define the data parameters needed on the surface of the Earth. And so we have continued that partnership. And one thing we do, of course, is we do spend a lot of time validating and providing some uncertainty information about these data products. That is all on our website, and we'll show a sample of that a little bit later. Then we've evolved our hosting environment and how we serve the data. It used to be on just a bare server serving ASCII data. Now we have migrated to the Amazon and cloud-based environment. I'll share a little bit about that. Finally, we've evolved in our analysis and distribution. So that means we've added more and more data formats to the output products and changed the way that we store all the products, made them available online and through GIS compatible websites like the Esri Living Atlas and NASA's own GIS Online. And so we've made the data products far more accessible, either for all of them in bulk for a large area, including the globe, or just for one particular location, as RETScreen usually does. And then we've also worked with a lot of educational outreach and continued to add partnerships through the years. So this is our cycle, and this is the way we continue to develop and improve, trying to listen to the community and how they're evolving in the use of these data products, making sure that we bring in the latest products from NASA research to help aid the community make the decisions they need to make. So with that background, I wanted to say just a little bit on where these data products are coming from. All the parameters related to solar irradiance are developed based upon our analysis of global satellite data. We had one project that combines all the world's geosynchronous and polar orbiting imagers from NOAA using radio transfer and lots of ancillary information such as aerosols and gaseous constituents of the Earth, surface albedos, and properties to do a radio transfer calculation and estimate the solar irradiance for a time history. And so our current data set uses this data set from this SRB, Surface Radiation Budget data set from 1984 through about 2000. But starting in 2000, a mission from NASA was launched, and it's called the Ceres mission, or the Clouds and Earth's Radiant Energy System. And they're spinning at the bottom left are two globes. This instrument measures the reflected energy from the Earth atmosphere system and the emitted thermal infrared energy to look at the balance of those two. And thus, it provides a very high precision measurement that helps constrain the calculation of the surface irradiance. And so they have provided a number of products. They're responsible for providing these hourly products, which we make available to the user starting in 2001. And also, Series has instrument is the one that we get our low latency products called Flash Flux. Those are only available on a daily resolution. So within a few days of the current day, we provide global daily estimates of irradiance. And then eventually when this hourly data set is available, it supersedes that. And so that's currently our solar irradiance. But through the years, as we interacted with the community, we found that they also needed information about the surface meteorology. So how hot is it? What's the maximum minimum temperatures? How about the surface skin temperature? These are parameters that are important for RETScreen, actually. And these come from a different process. It's called an atmospheric assimilation model. So this schematic gives you a little sense of what's happening. There's a GCM, a global circulation model, that is actually optimized using a whole host of observations, billions of observations, in fact. Beginning in 1984, they assimilate and constrain the model simulation with satellite measurements, but also airborne, like balloons from radiosondes, aircraft, surface measurements. So all those are assimilated and used to assess and optimize the output from the model. Then the model output is nudged and rerun. And so there's a loop here, and that results in the data products for the surface meteorology, including temperature. So definitely satellite information is available, is utilized in the in all those surface temperatures and humidities and winds that we provide, but those are all output fields from this model. We've also added a precipitation, a new data precipitation data set called the iMerge data product. It's part of the Global Precipitation Mission, and this is a higher resolution data product and daily from 2000 to present. So we've added new measurements and provide these products to help users make decisions with RETScreen and other tools. I mentioned validation, and we do spend time validating the data products and providing estimates of their uncertainty. One of the ways we do this is we compare the surface irradiance to highly calibrated surface sites that are distributed all around the world. And this figure in the upper right is a comparison of this Series SYN 1 degree product against those globally distributed baseline surface radiation network data, or measurements of the downward shortwave irradiance. And the point here is that this is at the this is the daily mean, and there is a nice agreement here. So we can derive all sorts of statistics regarding the bias and the RMS. We also have information on how various sites agree at different locations. And we do the same thing with those atmospheric reanalysis data products from NASA's assimilation system. So we compare those to surface measurements distributed all around the world. This middle panel shows estimates of the differences between those surface measurements and the irradiance, the surface temperatures provided from the model. The point is, it gives you a sense if there's a model bias in this area, but we've always seen that the day-to-day variability is very good and very useful for the decisions being made using the RETScreen tools. And we also, but we do look at these data qualities for all the surface measurements, whether they're wind or precipitation or winds or dew point. We compare those, all the surface measurements, to try to get an estimate of their uncertainty. Now, one of the things that we have done is migrated to the NASA managed Amazon Web Services cloud-based system. It's called the Mission Cloud Platform. And this is due to an agreement between NASA and Amazon. And so they've allowed us to serve our data products from this platform. And one of the issues that we had previously was reliability. And this was just because of the way the data center had to run and operate. It had to come down to do upgrades and replace equipment and those sorts of things. But that sort of issue is not nearly as prevalent in this environment. And so we found it to be much more reliable. And it's also much more flexible. We now have a serverless architecture. So when we add new products and services, we can just provide new modules. Everything is open. It's running with Python code. We have also migrated all our data products to cloud optimized data formats to make them readily available, both in bulk, but also by one location at a time. So all this has helped us serve RETScreen users and the public better by doing this. It also reduces some of the latency for data orders. So right now we have 4 different ways that you can either obtain data or visualize data, and we're still building and improving these, but we have built a complete application programming interface, or API, so that you can get any of these parameters directly from our website using a URL command. And if you'd rather, though, to get started, you can use our data access viewer, which is simply a interface, a user-based interface, provides a decision-based approach to selecting parameters for various communities and locations, and actually now provides visualization capability and analytics. I'll show you a quick plot of that. And we've also been developing geospatial services, including web image services and GIS, ArcGIS compatible image and features services. So we have those online, and you can go and then you can visualize either some of the parameters or analyze a parameter field. So in the background here, we have climate zones. I'll show you a little bit of that later. And then everything is now online with Amazon. So if you wanted to obtain the entire data product, you can actually go and select large versions for large regions, or all the data if you wish. So those innovations have helped us. But how do we send data to RETScreen? Well, the RETScreen interface has been unique, and we have maintained it through the years. But essentially now, on the right-hand side, we now process and update these data almost daily to keep it near real time. And those then are put into those cloud-optimized formats. And then when RETScreen's, if you're in the RETScreen module and in the performance monitoring mode, you will hit that button that says NASA data, and it'll send an API request for the standard parameters to our API, and the API will give you a response. Now, if you're in the feasibility study mode, a few years ago, we had delivered the entire database en masse to RETScreen, and they have embedded it into their software because it was a relatively coarse degree at 1 degree resolution. In the future, we can work to update this, because we do update our data products as the various science data products become available. But we have supported this way. We also continue to support older versions of RETScreen, but we'll be working with the RETScreen team when to sunset that capability. So I mentioned we have improved our analytics services platform, and this is just a quick example of that. We have a new data access viewer we call Data Access Viewer Enhanced, and it provides some analytics and the ability to make some new figures like a heat maps and time series maps, so you can interact with the data and visualize it right away. And then I've already mentioned the Amazon Web Services and the data catalogs now that the data are provided through. Now, what about our future plans? So we do have some future plans, and because we're continuing to evolve and improve our services and improve and expand the data parameters available. So this slide just gives a sense of the types of changes that should be coming. The Surface Radiation Budget Project and series are reprocessing and providing updated versions, and the series Flash Flux as well. So this year, the series Flash Flux will begin using a new satellite, and we should see a new version of Flash Flux within a few months. And then series is going to reprocess and provide new data products. This is all, this isn't something that the user has to, it's all transparent to the user, but we advise that when we change these, when these are upgraded, that we will have to re-deliver the climatologies because those could be changed. And also the NASA's Global Modeling Analysis Office system will be upgrading their atmospheric reanalyses, and we will make those products available when they're ready. We're also adding some data from new and different missions. So NASA has a soil moisture mission, and we have been requested to provide soil moisture. And then we have a new mission going up, which is a geospatial platform that is scanning the North America region and is providing air quality information. And there's some other missions coming in the future, which we'll look out for in terms of expanding and improving our data products. So, and one last effort that I want to mention is our development of climate risk services. And so we have a new project working with NASA centers, and we are using the new climate model results through 2100. And we have a special project within NASA that has taken those results and downscaled them to about 20-kilometer resolution. And we are assessing those for different NASA centers. For instance, here is the cooling degree days through 2100 for NASA Langley. And we can analyze those for decadal periods and then maybe even look at the differences between periods. This is differences by month. So we can see here at NASA Langley Research Center, which is in the southeastern Virginia, sorry. It is we can do this by month, and we can see differences in the decreases in the heating degree days, and we'll have increases in the cooling degree days as well. We've also derived maps for climate zones, and those are available so we can look at how maybe future climate zones changed. So at NASA Langley in southeastern Virginia, we've already changed from a 4 to a 3 in ASHRAE's classification, and the one model has us not model, but the suite of models for the most extreme conditions has us changing again in mid 2000s. So I'd like to just conclude here. We have had a long partnership with RETScreen and have enjoyed many years of working together, and we will continue to do so. And we have improved our data products and hopefully made them more reliable, and also reduced the time to get them and obtain them, and that they continue to be of use for decisions using RETScreen, and we are working to improve those as well. And we welcome all the feedback that you have. There's a number of ways to obtain all these data, and we just look forward to interacting with you and the RETScreen community. Thanks a lot.
Thank you, Paul, and all our presenters. This concludes Session 1, RETScreen Innovation Lab. Thanks for watching.